Okay, all of these good? So over the years, people came up with many a scale, and they are Celsius, Fahrenheit, and Kelvin. US uses, the rest of the world uses, and scientists use. Done. Yes.
That's a weird imperial version of the Fahrenheit scale, but there's all the way to 0.
Oh, Rankin.
Yeah.
Oh, I mean, this was when they were doing trial and errors with different things, and they were trying to come up with different ways, and everybody was trying to do a different thing, and you know, information was not easily transmitted in the entire world. But Rankin was the other scale. I think I have that in the book somewhere. So yeah, look that up. There's also I have also oh yeah, this is a good picture to remember, right? Celsius, Fahrenheit, Kelvin, freezing points, boiling points. What do you notice about them? There are a couple of things you should notice. 1, 2, and 3. Yes.
If it's 2 of those, it has a maximum range.
Yes.
It has a metered scale.
Yep.
It has a
resting point.
Resting.
Or a minimum point. Yes, absolutely. Right? So no matter which, and then what do all of them use? Why? Because it's cheaper. So what right? So yes, exactly. So any thermometer must have a scale. Any thermometer must have a resting point, and any thermometer must have maximum and minimum points. Here, Rankine, right? It's in here, Rankine, and these are the conversion factors. And these equations look really scary, right? Try to memorize all of them.
Oh God.
Exactly. Can I show you a trick on how to make that easy? And we are going to use the properties, the 3 ones that we've just talked about. And keep in mind, so all of this, well, not all of them, but all the conversions. So I'm just going to show you from Celsius to Fahrenheit, and then you guys can do the rest of the conversions. Okay. So those scary looking equations can be boiled down to if we fundamentally understand what these formulas are doing. So let's do this example. It is a very good example. I will not be memorizing any of the conversion. I will be using only one equation, and that is equation of a straight line. Why? Because when I was defining this thing for you, there was a word in them that I underlined. And that word was? What does the word linearly mean? A line. What kind of a line? A squiggly one? A straight line. Do we remember the equation of a straight line? Wait, what? Excellent. Now, do we fundamentally understand what those words mean? So if I write y equals mx plus b, do I understand what these words mean? Okay, take a second, think about it. What is y? What is x? What is m? And what is b? So draw this. I promise I won't come look at your papers. I want you to draw this exactly as it says without drawing a line. like a scale and stuff. Remember from the Tanya? What's the first thing you need to do? Define your origin. What's the next thing I make you do? What are they called? Your coordinates. So you need coordinates, which means you need X and Y, and you need your origin, X, Y, and what is B? So any point in which that line may hit, right? So now that you have that done, and you have this equation, what can you tell me? Okay? Read the example. And somebody read the example. Let's not all start.
The Fahrenheit temperature scale defines the freezing point of water as 32 degrees Fahrenheit, and the boiling point is 212 degrees Fahrenheit. Whereas Celsius temperature scale defines the freezing point of water as 0 degrees Fahrenheit. That should not.
Oh, Celsius. Yeah, that's me
0 degrees
copying wrong.
Celsius, and the boiling point has 100 degrees Celsius.
Yeah, change
Derive
that.
a formula that connects Fahrenheit to Celsius.
Okay. So what does that equation, what does that example tell me? So water Fahrenheit, Celsius. Freeze, boil. And divisions. Okay. On my Fahrenheit scale, where does water freeze? On my Celsius scale, where does water freeze? On my Fahrenheit scale, where does water boil? And on my Celsius scale, so how many divisions? 212 minus 32? And 100 minus 0? So that's the scale. Remember, for our thermometer, we needed what? A resting place, a division, freezing and cooling, right? Do we have the beginnings of a thermometer? Okay, now, if I was to take my y-axis as my temperature in my Fahrenheit scale, and I was to take this as the temperature in my Celsius scale, what's the B? 32? Good. That's done. Then what is my X? Agree? And I can leave my plus in here. What is my Y? Okay, what am I missing? I do not know my M. Okay, how do I find my M? Rise over run. So what will be my rise over run? Y1 minus Y2 minus Y1 over X2 minus X1. So is Y 100 or Y 212?
Y2 is
Is that right?
Yeah.
What's the answer?
1.8.
4 9/5. Got it? That goes in here. Do I get T equal 9/5 T Celsius plus 32. Drum roll. Recognize this equation in this one. Is it literally this one written the other way around? Or that one written this one? See? Suddenly those equations don't look scary anymore. Once you fundamentally understand what's going on. The first time we looked at this graph, right? We were like, oh, this is scary. It's not.